Hi there, welcome back to the channel, and welcome to the fifth video in the restoration of the SABA Meersburg 100 full automatic. Now, as you probably know if you've been following the series, the automatic wasn't working at all, well, not well, and this video is focused solely on that automatic adjustment. So I decided to redo the IF frequency because it seems that the motor transformer is optimized to a frequency which is not quite 460. The IF was previously at that frequency and I changed it to 460. I realized I might have made it worse, so I decided to go back and follow the whims of that little transformer. Sometimes you have to. So that's what I do in this video, and I go one step further. I want to probe certain points on that test socket with the scope while I sweep it. I'm going to sweep that P voltage, and it's very, very interesting what we get there and what we can glean from that kind of information. It's almost similar, it is similar to adjusting the discriminator or the ratio detector on the FM, because that's basically what you're doing here. And I also wanted to look at the broadband switch, you know, the one on the treble where you flick it all the way to the right of the treble and then you click it in and it changes the bandwidth of the IF. I wanted to see how that works. So if this sort of thing interests you, you want to see what it looks like when you change the bandwidth of the IF and how we can adjust the shape of that and see what it does to the shape of the narrow band, all that sort of stuff, and also how to trick the motor alignment to work better. Stick around and enjoy the video. But before we carry on, I just want to thank the sponsors of the video, PCBWay.com. They're running their 9th anniversary promotion at the moment, and this is an opportunity for you to get masses of free coupons. Go to the website, have a look around. There's coupons for orders over a certain amount, for certain types of orders. They're running an anniversary sale as well on PCB prototypes, assembly, advanced and flex rigid PCBs, discounts on 3D printing and CNC machining. And there's also the unboxing of blind boxes. Some pretty good prizes on here. You can also then visit the PCBWay store where you can get a lot of products and modules that'll just complete your workshop. So visit PCBWay.com. I'm sure you'll find something for you. Okay, I've decided to remove this whole mechanism because one of the reasons that the speed can be affected, as somebody mentioned in the comments, and this reminded me of the problem I had with one of these guys. I actually have removed one of these before, but it was one of the single button ones. Never mind. The idea is that the solenoid can take longer to switch from one side to the other when it's trying to change over. And if you don't have these switches cleaned, you've got a problem. Now, there are a lot of switches on here, but if I remember correctly, these aren't too difficult to remove. I removed 2 screws from here and 2 screws from the underside there. And this thing is now sort of loose. Now we've got wires coming to the 2 sides, and I noticed that this side only seems to have 2 wires going out. So I'll desolder those 2, and then I'll be able to, I think, flip this on its side like this. Now let me just have a look. See, there's those 2 wires, the brown and the orange, which I think is all that's holding this together or holding it in place. So I'm going to try and remove that. The brown wire is from this first solder tag and the orange one is from 3. So 1, 2, 3, 1 and 3. Let's see what I can do here. Looks like that black was also connected there. So there's 2 wires that I've desoldered, and I only wanted to desolder the one, so let's put that one back. And this one's also got 3 or 4 in here. Got to be careful with that. You can always go back to the schematic, but it's easier just to not mess it up. Okay. Those 2 are off. Now, is this going to work the way I planned it? Yes. Beautiful. Look at the state this thing is in. What are the chances of there being absolutely nothing wrong with this? Wow. Those switches are all black. Those are all black. And this is Just ready for a good cleanup. Now I've got to be careful that I don't break any of those wires there. So I'm going to do this very carefully, and okay, next time you see this, it should be sparkling. All right, it's time to put this thing back. This is all properly dried. It's all lubricated. So, looks like we're good. Now all I'm going to do is flip it over like this. I've got to solder those two, and I've got to remember that there's one that came loose, which I've moved through and clipped on there. So that should be good as well. Now this goes in here. Is that right? Yeah, I've got the two holes there, but I need to solder that in first. I believe that's one. The other one goes on there. I think we're good. Okay, we're good. Now, is that going to affect the speed? You know what, I don't really think so, but let's give it a try anyway. It's on medium wave. Switch this on. And seek. Exactly the same speed. I don't have an antenna in there. It's not even catching to the left. But it does go. But no speed change. So let's try something else. And I think this something else is what's going to do it. Okay, this is the second solution that I'm going to go for. Remember I told you that this capacitor was a bit high? That's the one I have doubts about because this one tested perfectly fine. This is 0.35 microfarads. That one's supposed to be 0.4. It was closer to 0.5. So what I'm going to do is remove that, and I've already desoldered the one side of it here. And I'm going to put in a different solution. I've got 4 100 microfarad capacitors here, 630 volts. I've put the 4 in parallel, so this should be 400. And I'm going to replace that capacitor with this and see what we get. Now, what we've got here is 411 nanofarads. Did I say microfarads? It's nanofarads. This is at 1 kilohertz. Now, this thing is supposed to work at 50 hertz, and the lowest I've got is 100 hertz. 394, so about 400, okay? I'm going to measure that one and see what we've got. Now, to measure that one, I've got this loose wire here. That's one side, and the other one comes to here. 553, that's pretty high. Okay, so let's replace this and see what we get. I'm going to just connect this temporarily and precariously, so be very careful. This has got very high voltage on here. I'm going to put this to that side, which is where that capacitor is supposed to go, and to here, which is where that wire was soldered to, and we should be good to go. Let me just make sure everything's okay so we don't get any surprises. That is on, so let's see what happens. Ha ha ha, yes. Perfect. Look at the speed of that thing. That's what I was used to, or am used to, on my Freiburg 9, Breisgau. Okay, so it looks like we've solved the speed issue. It was the capacitor value. And so I'm going to just put that in permanently, and we'll have one more step completed. Good. Okay, new 400 capacitor created with those 4 100 in parallels. Yellow heat shrink to match the one that was there. This is the actual sleeve that was on there. So what I'm going to do is put it back exactly where it was with a clip, and I think the thickness of this will allow the clip to work quite well. Let's try that. Okay, let's try that. Moving nice and fast and smoothly. So, and it's picked up a station. Another one. Another one. What about the other way? We found 3 coming this way. Nah. We've still got the same issue with that alignment. So, okay, we've solved the speed problem. We haven't solved the sensitivity problem. But I do believe it's got to do with that. Oh. Okay, it picked up that one because that's the local station, which is very, very strong. But anyway, the point is pretty speedy. Good stuff. Okay. One more task completed. Now let's see about that alignment issue. Okay, we're going to do a bit of sweeping, but this time I'm sweeping something else. And this was actually a suggestion that one of you made in the comments. I'm going to be sweeping while monitoring the response on that point P. In other words, that DC voltage you're supposed to get. So what I've set up is I've got the scope probing point P over there. And that's going into channel A, just like I did when I was checking the AGC response to the IF transformers, okay? And I've got the signal generator producing a sweep, which is centered on 460 with a span of 14 kilohertz. The time has got to be quite big in this one. You'll see why in a second. Now, if I get everything recording and start the sweep, this is what we get. Watch the scope. See that? Now, you can see that on the screen, but I'll point it out here at the same time. Might be easier. What we're seeing here is this is not a pure DC signal. I think that's 50 Hertz. I think that's the modulation coming in from the mains frequency. But as we can see, the peak is at 2 kilohertz. Remember, this is a span of 14, so each one of those gradicules is 1 kilohertz. There's 460, 458, 59, 458. So it's peaking over there. Now, I was trying to move this peak around. Let me just show you what happens if we make this too slow. If I make this 280 milliseconds and I change the time base, yeah, you can still peak it, but of course the 50 Hertz over there stays the same. I think that's 50 Hertz. So if I go to 1.4 seconds and I change this as well, that's the best we can get, but it's slow. It's a very slow response to any tweaking. So I prefer the 700 milliseconds one because I want to show you what happens when I tweak this. Now, keep your eye on the scope. Now, this first one that I'm going to do is the voltage adjustment to try and get a peak voltage. Now, watch that. It drops and it raises, but it still stays on the same frequency. That peak is still at the 458 or so. So this doesn't really change the frequency. This just peaks it, which means that that transformer is set to 458, which is why it seems they've made the IF 458. Now, if I go here and change the nulling thing, it does have some effect, and in fact the motor starts turning one way or the other. So I'm going to set it to stop, and I'm going to do this adjustment on 458, and I'm going to change the entire IF to 458. In fact, what I'm going to do is I'm first going to see what frequency exactly this thing peaks at by using just a voltmeter. Yeah, that's actually a good idea. Let me try that. Let me try that. I won't sweep it anymore. I'll stop the sweep. And that's what we get there. Let me hide this trace. make that trace invisible. I've got 26 volts over there, peak to peak. I've got a voltage measurement on there. So what I can do is I can come down now on frequency. If I change the frequency now slowly and see where it peaks, let's see what happens. That's gone up. Actually, now I can actually make this. Can I make this faster? No, this isn't a sweep. What I can do is change the time base so I get this thing moving faster, and I can put some, let me just set the trigger. I don't think it's going to trigger properly. Yeah, it's got RF in there, but I will be able to see, actually if this has got 50 Hertz in here, maybe I can trigger it from the line. Yep, there we go. I'm triggering it from the AC line voltage. I don't think I've ever done that before. Very seldom use that, but there we go. So we've got, what is it, 28, 29 volts. I'm going to drop this again a bit more. That's dropping to 22, 27, 29.2. Okay, let's get more specific. I think it was at 458.3. $29.77. See, it's coming down, goes up. Is that a peak? Yeah, 458. It's probably at 458.2 or so. I think that's where the peak is, but 458 is good enough. I'm going to set this thing to 458, change the IF to 458, and then I'll come and redo this at 458 and see if we get more success. Good. I want to thank you for that suggestion. It was a good one. Here we go. Everything is aligned to 458.3 kilohertz IF frequency, and that is the result we get on there. That's pretty clean, pretty uniform, looks pretty good. I've got the span at 14. Let me put the span at 28 kilohertz, so 2 kilohertz per division. We'll just move this down a bit. There we go, and we've got the 458.3 slap bang in the middle, and that's what we see. Now, there was one thing I wanted to show you, because somebody actually asked, and that is what happens when I change this to a different bandwidth. So I wasn't sure whether this was narrow or broad, but if I go to the end and I click it, watch the screen. Quite different, right? It's taken our amplitude way down, but it has actually done something else. Watch what happens if I change the sensitivity on here. Get this properly viewable. It's widened it for us. It's actually widened the bandwidth. You can easily see that. Sharp, right? Sharp. And less sensitive, but a heck of a lot wider. Takes a bit of playing around to get this nice and visible on the screen, but I think you get the idea. Now what we can do is actually play with the adjustments to try and get this thing straightened out and nice and uniform, and see what happens to the other one. Now, if I put this on 14 kilohertz bandwidth, it just looks like a hump. Watch. See that? So that's why I put it on 28, because it's widened that up completely. Now let me try and, I won't show you this, you can see what's happening on the screen, but I'm going to try and adjust this to try and get this thing uniform. We see the one side slightly lower than the other. That looks more like it. That's pretty good. Now that is a pretty good, yep, that looks beautiful. Now let's try and do it, see what this has done to the other setting. It's actually shifted a little bit to the left, but I'm actually inclined to leave it like that because it means that if I go to broad, I've got a very uniform passband. Yeah, okay, now we've seen what that does. All right, let me carry on. All right, I've done all that alignment. I've realigned the IF to 458.3, which is exactly where this thing peaked. I'm really following the whims of that motor transformer. It doesn't make much difference, you know, as long as you get this thing close, and then the RF alignment might need a bit of tweaking, but as I mentioned to you, this was at 458 anyway, or 458.3 if I recall correctly. So it seems that they had aligned the IF precisely the way I'm redoing it here. And I've done all the alignment. I've done the balancing and everything else. And the one thing you'll notice if you look at the screen is that that sine wave, well, it's sort of a sine wave, is actually a lot more uniform than it was before, just in the previous clip. And this has got to do with the fact that you're balancing it, and this is sort of similar to what you do when you do the ratio detector balancing in the FM. You actually adjust it so that you get the best sine wave with the least distortion, and it seems the same logic is being followed here. The other thing I notice is that if we look at the motor, it is perfectly still. Now they tell us that if we have this thing perfectly aligned, then that motor should stand still, or rather the automatic tuning should stand still. Now look what happens if I change this just a little bit. I'm at 458. Let's leave it at 458.3 and let's change it by 1 kilohertz to the right. It starts turning to the right, or left if you want to call it. Depends which way you're looking at it. Back to there, it stops. We go the other way, and it's turning the other way. And it's actually very sensitive. Watch this. I'm just going to change in the 100 kilohertz range. I've changed 400 kilohertz, and it's starting to turn. Can you see that? Let's go the other way. There we go. It's starting to change as well. In fact, it's a little bit more sensitive one way than it is the other. But what I found is that I can actually adjust the balance down there by looking at the motor. Let me show you. This is probably cheating, but if I do this, this is the balance adjustment. This is what you would adjust on that microammeter. And I've got to tell you that when I set this up like this now, depending on the strength of the signal coming in, it was balanced on the microammeter, but it was still rotating slightly. So it wasn't perfectly balanced. Now watch how sensitive this is. If we look at the motor, I'm just going to give it a little, oh, crikey. That was so small a twist. If I go the other way, there it goes. Now, if I stop it in the middle, I'm not even twisting the stick. I'm just sort of, that is how sensitive this thing is. There we go. I've got it. I've got it. And I've got to tell you, this thing is so sensitive, you won't believe it. But it's perfectly balanced now. If I go one way, and I give it 1 kilohertz to the right, it goes one way. And if I give it 1 kilohertz to the left, it goes the other way. And as you can see, it's still, actually now it's sort of still moving. So I've got to balance it again. It's almost like if you just breathe on this thing. In fact, what I'm going to do is I'm going to make the signal amplitude stronger. Oh, it's pretty strong as it is. It is very strong. So I'm going to just stop the turning. Yeah. There we go. I think that's now balanced. And if we look at the sine wave again, or rather the wave on there, other than a little bit more sort of modulation on the one side than the other, which I don't really understand. There's a reason for that, but I just haven't thought it through yet. That thing looks pretty uniform if you look at the envelope. So I think we've got this again. All right, time to test it. Got it on medium wave. It's, what is it, late morning. Don't expect much. We've got a storm here. We've got, is it hurricane or whatever, Oscar flying through Madeira. But let's get cracking. Canary Islands.
A posibles shocks que se produzcan en este programa. Es amplio. Es amplio, claro. Es que es bueno el tema. Como el de Ramón, pero...
Okay, let's try the other way. I noticed that it is more sensitive one way than the other.
Bueno, ¿has puesto a coger el metro? No.
It caught it.
Esta es la presión puesta en el radio pool.
Yeah, you see it's just missing a couple that are there. And if I go this way, you see it stops. It's catching better on the one way than the other. But I've been told that this is pretty normal. I don't know why. And when I look at that screen again, it's sort of, I don't know why you got more RF on the top part of the waveform than on the bottom part of the waveform. And it might have something to do with it. I'm just making things up as I go here, but I suspect it's got something to do with that. I don't understand why. But anyway, the point is, I've read a lot of forums. A lot of people say that this can be a lot more sensitive one way than the other. I've just found out mine is like that. And I'm going to leave it like that because I've really farted around far too long with this motor. And quite frankly, I don't think I'm going to use this. In fact, I've got a perfectly good Freiburg 8 over there, and I never use the automatic tuning. You know, you get used to what you're listening to. If you're doing it on AM, like medium wave, short wave, or even long wave, you're just trying around, you're de-axing, you're playing around. You're not going to sit there and do automatic tuning because nowadays we don't have very strong local stations. We have one, but I don't listen to that. So that on AM is almost never used. On FM, what seems to happen is you end up with a favorite station and you set it there and that's where it stays. Sometimes you go along just to see whether it's receiving on the other end of the band. But other than that, I never use it. Now, the point is not whether I'm going to use it or not. The point is we're restoring a radio. If you're restoring it, you restore it to the condition it was meant to be when it came out of the factory, or better in some cases. So it doesn't really matter whether you use it or not. The point is it's got to work, and that's what I'm happy with. I've got this thing to work. I'm not sure whether the sensitivity, the one way, can be improved dramatically. I'm not going to head down that rabbit hole. But the point is, I've got it set to where it's functioning, presumably the way it came out of the factory. And I certainly have learned a lot about this motor tuning. Now, every time I do one of these, I've got to restudy the motor tuning because it's the sort of thing that just raises questions all the time. And quite honestly, I don't really mind that. I enjoy this. This is a hobby. This is the challenge. The whole point is that you take on these little challenges to learn from them. And I certainly have. So this is where I'm going to leave you for now, with the automatic tuning, actually with the entire IF alignment and automatic tuning on the AM completed. I have not done the FM, I've not done the RF alignment, but those I will tackle in the near future. So once again, I hope you've enjoyed that, and if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can certainly do so on Patreon and PayPal. Links are in the description below. Thanks for watching, bye for now, and stay safe.